Hello, hi guys. Am I audible? So sorry for the delay, but okay. We are here. We'll start in just 2 minutes. So how was the contest? Yep, the contest is declared unrated due to the D problem that had a odd statement. So yep. Okay, we'll be discussing the A, B, basically A, B, C, and E1, E2. These would be the problems we'll be discussing today. D, I was reading, I had solved for the wrong statement, which was giving wrong answer. So I haven't thought for the correct statement yet. So not discussing that. But then I have solved E1, E2. So we'll discuss that. Okay. Okay. I guess we can start now. So just confirm once if my screen is visible. And yeah. Okay. So hi everyone. I'm Abhinav and welcome to the post-contest discussion of the Codeforces Round 1048. So we'll start with, we'll be discussing the, okay, we'll be discussing ABC and the easy as well as hard version of the E2 problem today. Okay, so I guess we can start with the first problem. So in the first problem, it's given that Maple has two positive integers A and B. C may perform the following operation any number of times. Yeah. C may perform the following operation any number of times to make A equal to B. Choose any positive integer x and multiply either A or B by x. So this is the operation that he can perform, multiply either A or B by x. And what he need to do is minimum, you need to determine the minimum number of operations required to make both A and B equal. And it can be proven that it is always possible. So minimum how many operations would be required to make both A and B equal using these operations? That's what you need to answer. Constraints are till 1000. So basically the problem states that okay. So just a second. Yep, screen is visible, right? Okay, so basically the problem states that you are given two integers A and B, and what you need to do is you need to make both A and B equal, and the operation that you have is just pick any integer x and multiply A by x, or pick any integer x and multiply B by x. So this is the operation that you can do. You multiply A or B by any integer, and by doing this operation minimum number of times, you need to make A and B equal. This is what you need to achieve. So for example, if you look at these test cases, let's look at all the test cases. So in the first test case, A is given as 1, B is given as 2. So what you can do, you can just perform one operation, make multiply A by 2 and make it 2. So A would become 2 and B is already 2. So they become equal by doing one operation. So 1 is the answer for first test case. Second test case, you have A is equal to 10 and B is equal to 3. So like in one operation, you cannot do it even if you try. So what we can do here is you can maybe multiply A by 3, let's say 10 into 3. So first operation would be multiply a by 3 and make it 30. Second operation would be multiply b by 10, let's say, and make this also 30. So after doing these two operations, you have made both a and b equal. So for this, minimum two operations are required. In the third test case, a and b are already equal, so no operations required. Minimum operations would be 0. So these were your answer 1, 2, and 0. So I hope just by doing this analysis only, you would have got what we need to do actually. So we can divide it into cases. If a and b are already equal, then our answer would be 0. No operations are needed. If a and b are unequal, then we know 0 would not be our answer. We would have to do at least one operation. When can we do it in just one operation? When either a is divisible by b or b is divisible by a. When either of the things happen, like a is 5, b is 10, then if they are divisible, we can multiply a by 2 and make this also 10 and make both of them equal. Or if let's say b is 6 and a is 12, then we can multiply b by 2 and make them equal. So we can do it in one operation only if either we can multiply one of them and make it equal to other. That means one of them is a multiple of other. So if a modulo b is 0, that is a is a multiple of b, or b modulo a is 0, that means b is a multiple of a. If either of these cases happen, then you can say you can do it in just one operation. And else, if they are not multiple, then that means we cannot do it in 0 operation, we cannot do it in 1 operation. So if we can do it in 2 operation, that would be the minimum. So you can see you can always do it in 2 operation, just multiply a with b and multiply b with a. So if you do something like that, you can always do it in 2 operation, whatever the numbers be. So in the else case, we can say that our answer would be 2. So this is the basically our code that we need to write. Okay. I hope the first problem is clear to you. So if we look at the code for the first problem, okay, so we take a and b input. If a and b are equal already, we print 0 as our answer. If a is a multiple of b or b is a multiple of a, we print 1 as our answer. Otherwise, we print 2 as our answer. That's all our code is. Time complexity would be obviously order of 1. We are just writing some if else statements. Space complexity is also simple 2 variables, so order of 1. Okay, I hope there is no doubts in the first problem. It was fairly easy problem. I guess we can move to the second problem now. Okay, so second problem what we have is Maple wants to bake some cakes for chocolate and vanilla. One day she discovers n magical cake ovens. The ith oven bakes AI cakes every second. The cakes remain in their respective ovens until they are collected. Okay, so basically there are n cake ovens, and for every oven there is a value given to you by the array AI. AI is the number of cakes that are baked every second by that particular oven. At the end of each second, C may teleport to any oven, including the one C is currently at, and collect all the cakes that have accumulated in it to that point. So at any particular second, what she can do is she can go to any one of the oven and collect all the cakes that have accumulated till that point of time there. So she can do that for any one particular oven only in 1 second. Okay, she cannot go to more than one oven. Your task is to determine the maximum number of cakes Maple can collect in m seconds. So in m seconds, how many number of cakes he would be able to collect? That's what you need to answer. Okay, constraints are n is up till 10 to the power 5, but m is up till 10 to the power 8. Okay, so you cannot iterate up till order of m because you have t-test cases as well. Sum of n is 2e5. So order of n is the required term complexity. So if you look at the test cases, let's suppose if we look at the first test case, n is given as 3, m is given as 4. So you have an array of size 3. That means for the first oven, it bakes 1 cake per second. The second oven bakes 2 cakes per second. Third oven bakes 3 cakes per second. and you have like 4 seconds of time. You can, so if you have 4 seconds, then at the end of first second you would collect some cakes. At the end of second you would collect some cakes. Third you would collect some, and at the end of fourth second you would collect some cakes. Okay, you would collect cakes only at these 4 points, and at these 4 points you can collect cake from any one oven only, not more than one oven. Okay, so after the, like you can say, after the first second, the number of cakes that would have accumulated would be, in the first oven it would be 1 2 3. Okay, after the first second. After the second, if it is not collected, then one more cake would come here, here two more would come, here three more would come. Same after the third second, if it is not collected, then 3 6 9, like that. If they are not collected, then this is what would be the number of cakes present. Okay, now what is the maximum number of cakes you can collect? So what we can do is, like, we can think of this greedily. Like, if you have more than n seconds, that means like you can go to every oven at least once and collect the cakes from them. And it does not matter, let's say in some first second you collected a cake from the first oven, and in fourth second you again collected a cake from the first oven only. Then even if you didn't collect a cake in the first second and you collected only in the fourth second, still all the 4 accumulated cakes would be present there and you can collect all of them. So it is not required to go to a particular oven more than once, because if you are going to a particular oven at time t1 and at time t2, then if you are collecting some x cake at this time, then at time t2 whatever cakes that would have accumulated, so it would be ai multiplied by t2 would be the number of cakes that would be accumulated at time t2. Then if you are collecting x cake at this time, then the remaining cakes would be this much only. So the total sum of cakes would be ai into t2 only. Even if you collected 0 cake here, still you would have got ai into t2 cakes only. So we can say that at every oven, it does not matter if you collect the cake more than once. So it would be best to collect the cake only once. And how do you most optimally maximize your total number of cakes? So what you would do, you would collect in the last n seconds only. You have m seconds, but you would collect only in the last n seconds. So, and what would be the more beneficial to go to which one? So in these 3 seconds, once you would go to oven number 3, once you would go to oven number 2, once you would go to oven number 1. But what should be the order that you should follow in order to maximize? So in the fourth second, the number of cakes present at any particular oven would be ai into 4. At this point of time, it would be ai into 3. At this point of time, it would be ai into 2. So if you collected the cakes, if you, let's say, collected some ith oven here, jth here, and kth here, then we can say that the total number of cakes would be collected would be ak into 2, aj into 3 plus ai into 4. This would be the total number of cakes collected. So you can see that it would be just whatever the array values are multiplied by increasing order of the last n values of m. So if m is 4, it would be 4 3 2. If here m was 6, it would have been 6 5 4. Okay, these would be the coefficients here. So how do you maximize this value? It would be maximized if with the maximum value, the array value with maximum goes with maximum, then only we can maximize it. Because if you have greater value going with getting multiplied by 4 as compared to smaller value getting multiplied by 3, that would be more beneficial than having a smaller value multiplied by 4 and greater value multiplied by 3. So basically what we need to do is, in the last second where we would have the most amount of time, there we would pick such a which having greatest value, then the next greatest, then the next greatest. So if we basically sort the array in reverse order, then we can say that after sorting, the greatest value would be here, the second greatest value would be here, the third greatest value would be here, and so on. after sorting the array. That's what I'm saying, sorting in reverse order. So your final answer is basically for a given n and m, your final answer is n array size n. First, sort the array in decreasing order. Once you have sorted the array in decreasing order, so it has values in decreasing order, then you can say that your answer is the greatest value multiplied by m plus second greatest value multiplied by m minus 1 plus third greatest value multiplied by m minus 2, up till you would go up till either the last, you would go to the last value in the array. So if n is greater than n is less than m, so if the number of values present in the array is less than or equal to m, that means you can go to all the values. So this would be multiplied by just m minus n plus 1 for this case. And if n is less than m, then your answer would be, then you can go to only the greatest m values. The remaining would remain. So this would add up till a whatever you go, so that m becomes 1, until m becomes 1 at whatever index you go. So this would be basically your answer. I hope you understood. Okay, so basically what we need to do is just sort the array and keep keep reducing the value of m and multiplying it with a until either m becomes either m becomes 0 or I reaches n. Okay, we would break with either of the conditions. So if we look at the code, what we do is we take the input. After that, we sort the array in reverse order, and then I start with I equal to 0, go up till either I is less than n or my m becomes 0. Okay, so I keep on reducing my m after every operation. In my answer, I add m multiplied by ai. Okay, so m multiplied by ai gets added, then m gets, we do m minus minus, so next value would be m minus 1, then m minus 2. We keep doing m minus minus until m is greater than 0. I can like it strictly greater than 0 also. For equal to 0, we would add multiplied by 0 only, so it won't affect our answer. So we can write greater than 0. So either m is greater than 0 or I is less than n for 0 based indexing. This would be our break condition for the loop. We keep adding to the answer and print our answer. Okay, so I hope this would be clear to you. I can't predict the rating, but maybe 1100,000 or 1200 maybe. I don't know. It was pretty easy problem only. No. Okay. So I hope there are no doubts in this problem. If you analyze the time complexity, this input part is taking order of n time. This sorting would take n log n time, and this loop is running at max n times only. So this is order of n only at max. So your time complexity would be order of n log n. N log n is the worst case for sorting. And your space complexity would be just, you are using the input array of size a, nothing else. So the input array is only used order of n. Okay, so I hope this problem is also clear. So I guess we can move to the problem C. Okay, so let's move to problem C. Chocola and Vanilla loves cakes. Today, the manager of a cake shop gave them a total of 2 to the power k plus 1 cakes. The cakes were distributed evenly, so each of them initially received 2 to the power k cakes. Okay, so there were total 2 to the power k plus 1 cakes. So both Vanilla and Chocola received 2 to the power k cakes each. However, Chocola and Vanilla now wants to redistribute the cakes such that Chocola ends up with exactly x cakes and Vanilla gets the remaining 2 to the power k plus 1 minus x cakes. Okay, so now in one step, they can perform exactly one of the two operations. So initially you start with a state where both of them has 2 to the power k cakes each. You want to reach a state where the first person has x cakes and the second person has the remaining cakes. So in order to do that, you have two types of operation. First is Chocola gives half of her cakes to Vanilla. The operation is only allowed if Chocola currently has an even number of cakes. So if Chocola has an even number of cakes, he can give half of her cakes to the other person. Same the operation 2 is if Vanilla has an even number of cakes, she can give half of her cakes to the other person. Your task is to determine the minimum number of steps required to reach the target distribution and to output a valid sequence of operations achieving that minimum. So what is the minimum number of steps required in order to reach this distribution and any valid sequence which achieves that minimum? And it can be proven that under the given constraints, a valid solution always exists in less than equal to 120 steps. So you don't need to prove that, it's already given in the question that it can be proven, so you can assume that it is always possible. Okay, so now this is the problem. So if you look at some example test case, let's look at this test case. So this is your n and k. Yep, so not n and k, input is k and x. This is your k and x. So k is the initial number of cakes that one has. So 2 to the power k plus 1 are the total number of cakes present. So basically each of them have 2 to the power k and 2 to the power k cakes. So here k is 3, so each of them has 3, 3 cakes. You want to reach a state where, sorry, not 3, 2 to the power 3 and 2 to the power 3. So 2 to the power 3 is 8 and 2 to the power 3 is 8. So each of them has 8, 8 cakes. You want to reach a state where the first person has 7 cakes and second would have the remaining number of cakes, which would be 9. So from here you want to reach this state. And in order to reach this state, the allowed operations are that either you can take the first person, reduce his cakes to half and give it to the other person. This is one kind of operation, or you can do it other way around. Reduce this to half, give it to the other person. These are the two types of operation that is allowed. By doing these operations again and again, you want to reach this state, and you want to minimize the number of operations to reach this state and also print what operations you would do. Okay, so for this particular test case, what was a way to do it? What you can do is you have 8, 8, you want to reach 7. So what you can do is if you reduce the first one to half and increase the other one, it would become 4, 12. And then if you give 6 here, okay, what is the answer for this? It is 2, 2, 1. Okay, so 2 was the second person gives to the first person. So if this gets reduced to half and gives to the first person, it would become 12, 4. Okay, and then again if this person gives to the other person, it becomes 14, 2. And then this person gives to this one, it becomes 7, 9. Okay, so here you required 1, 2 and 3 operations to reach your required state. So these would be the operation. Here second type of operation was performed, right one giving to the left one. Here also second operation was performed, here first operation was performed. So your answer was 2 to 1. Okay, so this is what you need to do, this is what you need to find. Okay, so how do you do that? So in order to understand the problem, what we can say is try to look at the operations from the reverse. Like if you try to think, you would always have like 2 operations, and only case where you won't have a 2 operations when you get to something like where there are odd numbers. Now since the total number of cakes are 2 to the power k plus 1, which would be an even number always. So if one of the person has an odd number, then other one would also have an odd number, you know for sure. So once you reach a state where both of them has odd values, you basically cannot perform any operations further from there. So you can only perform operations until both of them have even number. And till both of them even have even numbers, you have like both type of operations open. And if you just try to look it in the forward direction, it becomes a bit complex to analyze. Like you have always have two options, which one would be the more optimal to choose. And if you like do the brute force approach of always going to 2 options, it would be like going to all the states would require going to all 2 to the power k plus 1 values of x, which would be 2 to the power 60, which is 118, would obviously give you a TLE. So you cannot recursively like explore all the options, because that would go 2 to the power 60 states, which would give you a TLE. So how do you think of this problem? So a way to think of this problem is, let's think in reverse. You start with a state of 2 to the power k comma 2 to the power k, and your target state is x comma 2 to the power k plus 1 minus x. This is your target state where you need to reach, and this is a state with which you start with. Okay, so let's perform the operations in reverse and think that you start with this state and you want to reach this state. Okay, so if you think of the operations in reverse, so if we have, if first person has a number of cakes and second person has b number of cake, let's suppose, we know that it would always be equal to the power k plus 1. The sum of cake, this would always remain constant. Okay, and after the next operation, when you perform an operation, either there would be two cases, either b gives to a, so number of cakes with a would become a plus b by 2, and with b would become this, or a gives to b, then it would become a by 2 and b plus a by 2. So these are the two possible cases for the two types of operation. But if you think in the reverse order, that you are at some state x comma 2 to the power k plus 1 minus x, you are at this state, what would be the previous state? What would be the state before you perform your last operation? Let's say your previous state is a comma b. Okay, what equation can you write? So the first thing is a plus b is equal to 2 to the power k plus 1. Okay, and then from here you perform an operation to reach this state. So either you would perform an operation to reach a state with either you reach a state by making a as half. So either you reach a state of like these two, a plus, either you reach a plus b by 2 comma b by 2, or you reach a by 2 comma b plus a by 2. These are the two states where you can reach from here. So once we would check for this state, if we think that this is x comma 2 to the power k plus 1 minus x, and once we would check if this is x comma 2 to the power k plus 1 minus x. Okay, so for this case we can say that if this state is this, that means a is equal to x, sorry, a plus b by 2 is equal to x, a plus b by 2 is equal to x. This is first equation, and other equation we have is this. So what would be our a and b? So here if you substitute the value of b from this, then we can say that a plus, what is b by 2 from here? If you like reduce it, then b would be 2 to the power k plus 1 minus a. So b by 2 would be 2 to the power k minus a by 2. This would be b by 2. So you can replace it here. So a plus 2 to the power k minus a by 2. 2 to the power k minus a by 2. This is equal to x. That means a by 2 is equal to x minus 2 to the power k. A is equal to 2x minus 2 to the power k plus 1. So this is like one solution, that if you are at a state x comma 2 to the power k, if you are at a state x, then your previous state would be 2x minus 2 to the power k plus 1 if you had went through this operation. And if you went through this operation, then what it would be? It would be a by 2 is equal to x. That means a is 2 into x. So this is your other option. So that means if you want to reach a state where your value of a is x, then your previous state was either 2x or 2x minus 2 to the power k plus 1. That means your previous state was either 2x comma whatever the remaining number, or 2 to 2x minus 2 to the power k plus 1. So if you look at these two numbers, now you know for sure always your a and b, they cannot exceed 2 to the power k plus 1. These are the number of cakes available to you. So at any point of time, your either a or b, they cannot exceed 2 to the power k plus 1. That means the other one would become negative, which is not possible. So if this x is, if I'm saying this x is less than 2 to the power k, or if I'm saying this x is greater than, let's say if x is greater than 2 to the power k, then in that case 2x would exceed 2 to the power k plus 1. It would become greater than 2 to the power k plus 1, which means this state would not be possible. And if you look at 2x minus 2 to the power k plus 1, then 2x would exceed 2 to the power k plus 1 minus 2 to the power k plus 1 would give you a positive value. So for x greater than, what we can say is, what we can conclude, for x greater than 2 to the power k plus 1, only one state is possible, which is 2x minus 2 to the power k plus 1. This state is not possible. We can come to this state only through 2x minus 2 to the power k plus 1. And if you look at the other case, where your x is less than 2 to the power k, then this 2x would be okay. It would be less than 2 to the power k plus 1. But if you look at this number, then this 2x is less than 2 to the power k plus 1 minus 2 to the power k plus 1 would give you a negative value. It means this state would not be possible in that case. So for x greater than 2, for x less than 2 to the power k, only one state is possible, which is 2x. So we can see, if we go in the reverse order, when x becomes equal to 2 to the power k, our job is done. We wanted to make x equal to 2 to the power k. This is what we want to reach if we are going in the reverse order. So when that happens, that is okay. But until it is unequal, either of these two cases would be there. And for both of the cases, there is only one valid state. That means if you think in the reverse order, then going from this state to this state, there would be only one possible path to go from this to this. So we can conclude, if you want to go from this to this, there is only one possible path. If you follow any other path, you would not be able to reach this state. And whatever that one possible path is, the length of that path would only be the minimum, because that's the only possible path, and that is what you need to print. So what you can do is, if you think in the reverse order, then depending on value of x, if it is greater or smaller, you can decide whether you are doing operation 1 or operation 2. What would it be? Like from B to A, this transfer was operation, what was, vanilla gives half to chocolate. This was operation 2. Okay. So this was operation number 2, and this was operation number 1. So that means with operation number 2, you obtain 2x minus this. So this is obtained with operation number 2, this is obtained with operation number 1. Okay. So if x is less than 2 to the power k, you would say that you apply operation number 1 and backtrack to 2x. If x is greater than 2 to the power k, you say that you apply operation number 2 and backtrack to this value. Then update your x with this value, again keep on repeating it. So in reverse order, you would get the operations that were applied. If you reverse that, you get the order in, you get the correct order if you do in forward direction. So, and you know the number of operations would not exceed 120. So in at max order of 120, your loop would go at max order of 120 and your job would be done. If this is clear to you, please tell, or if there is any doubt. Like, what is the part part that is not clear to you. What I'm doing here is I'm trying to think in the reverse order. The actual operations was you are at this state and you want to reach this state. So in forward operations, there were like two possible state, that if you are at AB, you can reach to this state or this state. But if you think in the backward direction, that you are at some state x comma 2 to the power k minus x, then what is your previous state? If you think in the reverse order, then either you came to this state through operation number 2 or you came through operation number 1. These are the only two possibilities. So if we came, so what I'm assuming here is, okay, let me explain once more clearly. If you came to this state x from the first type of operation where you did something like this, if you came from this operation, that means this is your current x and this is your previous x. This a is your previous x in the before applying the operation. That means whatever was your previous x, which is a, this is what we need to calculate. If we can calculate this a, we got our previous state. So we can write a plus b by 2 is our x. A plus b by 2 is our x in order to calculate the previous state. And if you substitute from this equation the value of b, what you finally get is the value of a is 2x minus 2 to the power k plus 1. That means if we come from operation number 2, so if we come through operation number 2, then our previous state is 2x minus 2 to the power k plus 1, comma, the remaining would be 2x only. Yes. And if we came here from operation number 1, then same way we can say that current value is a by 2, previous value was a. That means previous value was 2 times the current value. A is 2x. That means the previous state was 2x comma 2 to the power k plus 1 minus 2x. Okay. So now if you look whether this state is valid or this state is valid, then if x is less than 2 to the power k, then this state would be valid, 2x would be in the range, but 2x minus 2 to the power k plus 1, this would become negative. So for this case, we can come from only this state. This is an invalid state. And same way, if you look at x greater than 2 to the power k, then if x is greater than 2 to the power k, that means this 2x would become greater than 2 to the power k plus 1, which would make this b value negative, which means this state would be invalid. That means you can come only from this state. So depending on your value of x, you can, there is only one state possible from which you can come to this state. So you can do the operations in reverse order, start with this state, and whether the value of x is greater than 2 to the power k, apply operation 2 and update your value of x. If it is less, apply operation 1 and update your value of x. This way you would get the operations in reverse order. If you reverse that vector, you get the operations in straight order. I hope it would be clear now. So if it is clear, I think we can move to the code. So we take the input k and x, and now what we do, we would apply the operations in reverse order, going from this state to this state until this x becomes 2 to the power k. When this x reaches 2 to the power k, our operations are done. So while x is not equal to 2 to the power k, until x is not equal to 2 to the power k, we'll keep upon applying the operations in reverse order. And what we do is, if x is greater than 2 to the power k, so if x is less than 2 to the power k, we apply operation 1. If x is less than 2 to the power k, we apply operation 1 and make x as 2x. We multiply x by 2, update x to 2x. Otherwise, if x is greater than 2 to the power k, we apply this operation number 2, apply operation number 2 and make x equal to 2 to the power x minus 2 to the power k plus 1. Okay. After doing this, if we reverse our answer vector, that is our answer in the correct order. And we can print the size of the answer and all the elements of the answer. Okay. I hope the code is clear. If you analyze the time complexity, this is just input part. Then this while loop, as we know from the problem statement, our answer would have at least 120 steps only. So this while loop is running at max the number of steps in our answer. So this would be at max, this would run at max 20 times. Reversing the vector would also take at max order of 120, the size of the vector. Printing it would take at max 120. Okay, so we can say that the time complexity would be at max order of 120 only. Okay, and space complexity, if you analyze, then we are just using constant values and a vector which may take a size up till 120. So this would have a order of 120. Okay, I hope this problem is clear to you. Is there any other doubts in this? Extension is CPH. You can search on Google, and VS Code also, CPH, competitive programming helper. Okay, any other doubts regarding this problem? Okay, so I guess we can move to the next problem now. So next is E1 and E2. We'll discuss both of them together. We'll directly solve the hard version only. So only the difference is in the constraints. We'll discuss what difference these constraints make, but let's read the problem first. Okay. So Maple is given a rooted tree consisting of n vertices numbered from 1 to n, where the root has index 1. Each vertex of the tree is labeled either 0 or 1. Unfortunately, Maple forgot how many vertices are labeled and only remembers that there are exactly k zeros and n minus k ones. Okay, so you have a tree of size n containing n vertices with 1 as the root of the tree, and every index is labeled either with 0 or with 1, but you don't know exactly what they are labeled, but you know that there would be a total of k zeros and n minus k ones present in total in the tree. For each vertex, we define the name of the vertex as the binary string formed by concatenating the labels of the vertices from the root to the vertex. So the label, the name of the vertex is defined as whatever label, that label would be 0 or 1. So the name of u would be whatever is the name of the immediate parent of u plus the label. So basically the name is, if you start from the root and reach this node, in that path starting from root to reaching this node, whatever labels are coming, concatenation of that is the name of the any vertex. So this and this, the beauty of the tree is equal to the length of the longest common subsequence of the names of all the leaves. So the beauty of the tree is defined as the LCS of the names of all the leaves. So if you look at what are leaves in a tree, nodes having no children. So all those nodes which do not have children, the leaves of the tree, if you consider the names of all those nodes and take the longest common subsequence among all those leaf nodes, that is called the beauty of the tree. Your task is to determine the maximum beauty among all labelings of the tree with exactly k zeros and n minus k ones. Okay, so that labeling is not fixed. You can decide the labeling, but with the given constraint that there should be exactly k amount of zeros, n minus k amount of ones. With that restriction, whatever valid labelings are present, among them, what is the maximum beauty you can get? For which particular labeling you can get a maximum beauty? You just need to answer the maximum beauty for any particular labeling. Okay. So constraints in the easier version is n is given till 1000. In the harder version, n is up till 2 into 10 to the power 5. Okay. So no issues. We'll look at both the versions. Let's understand with one sample test case. Okay, so here in the input you are given n and k along with the parent array. So parent array starts with 2, 3, 4, 5, 6, 7 is denote the parent of 2 is 1, parent of 3 is 1, parent of 4 is 2. So we can form the tree. 1 is the root node, the parent of 2 is 1, that means 2 is at the child. Parent of 3 is also 1, that means 3 is also a child of node 1. Parent of 4 is 2, that means 4 is a child of 2. Parent of 5 is 2, 5 is a child of 2. Parent of 6 is 3, so 6 is a child of 3, and for 7 also it is 3, so 7 is a child for 3. Okay, this is the tree given to you. For this particular tree, the value of k given to you is k is equal to 3. You can have 3 zeros and n minus k is 4. So you can have 3 zeros and 4 ones present. You can label these using 3 zeros and 4 ones, so that the final name of these leaf nodes, if you consider their names, their longest common subsequence, their LCS, longest common subsequence, is maximum. So if we do the most optimal assignment here was if you assign this as 0, this as 0, this as 0, and these as 1, 1, 1, 1. What is the name do we get? So the name for this leaf node would be, if you start from the root, what path you would follow to reach this leaf node? 0, 0, 1. So the name of this would be 0, 0, 1. What is the name of this leaf node? This is the path you would follow from the root to reach here. So 0, 0, 1. Okay. So here also it would be 0, 0, 1. What is the name of this leaf node? This path 0, 0, 1. Name of this leaf node is 0, 0, 1. Name of this leaf node is this path. So 0, 0, 1. Name of this leaf node is 0, 0, 1. Okay. So if you look at all these 4 strings for all the leaf nodes, they all are 0, 0, 1. So longest common subsequence is basically 0, 0, 1 only. So its length is 3. 3 would be your answer for the first test case. Okay. If you look at, let's say, one more test case, let's look at this given test case. So if you look at here, then here this was the tree given to you, and there the value of k was k given here was 2. That means you can have 2 zeros, and n was 7. That means you can have 2 zeros and 5 ones. Okay, so the assignment that was made here was, here it was given 1, here 1, here 1, 0, 0, 1, 1. This assignment was made here. So if you look at the names, then for this leaf node you are coming from 1 to 6, so its name was 1, 1. For this leaf node 1 to 1, 1, 1. For this leaf node 1, 0, 1, so 1, 0, 1. For this leaf node 1, 0, 1, so 1, 0, 1. If you look at these 3 strings, what is the longest common subsequence? If you start with 1, if you take 1, 1, if you take 1, 1, 1, 1 comes here also, 1, 1 comes here also, 1, 1 here also, 1, 1. So 1, 1 was the longest common subsequence having size 2. So 2 was your answer for this particular test case. I think is this test case is, I think, the second test case whose answer was 2. Okay. So now you have seen these test cases. Let's try to think now, how do we optimally do an assignment so that we maximize the longest common subsequence. So if you look at any general tree, something like that. Okay. Now, if you look at the leaves of the tree, first of all, what you need to look is leaves of the tree. Like, you need to maximize the LCS for the leaves of the tree. So for this tree, the leaves are here, 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 here. Okay. They can be at different levels. What would be the name of a leaf? It would be starting from the parent till reaching here. Whatever strings are coming, their concatenation. So if you look at the length of the name, for any node, what would be the length of the name for any node I? It would be, if I'm at this node, then one character from here, one from here, from one from here, one from here. So if you divide this tree into levels, okay, this is first level, this is second level, this is third level, this is fourth, this is fifth. You can always divide a tree into levels, or you can say depths. Okay, so this we can say is depth level 1, this we can say is level 2, this is level 3, this is level 4, this is level 5. So for any particular node, its name, if it is at the fourth level, it would have 1, 2, 3, 4 characters in its name. So the length of any name would always be the level of that ith node. Okay, so what is the maximum LCS you can get ever? It would be, among all the leaves that are there, whichever leaf has the minimum length, if you can make the LCS equal to that particular length, that is the maximum you can get. Like here, if you look at this test case, you had two strings having length 2, you had two strings having length 2, and two strings having length 3. The maximum LCS you could have got is 2. You cannot get an LCS of 3 with a string of size 2. So whatever is the minimum length, that's the maximum you can get ever. If it is possible to make that, that would be the maximum. If not, then anything less than that. So first we would try if we can make that as our possible answer. Then that would be the maximum for sure. So which would be the leaf that would decide our minimum length? It would be the leaf at the minimum depth. Okay. So if you look at these, here we have two leaves at a depth of 4. These leaves are at a depth of 5. So 4 is the minimum depth where we get a leaf. Before level 4, at level 3, there were no leaves. At level 2, there were no leaves. At level 1, there were no leaves. 4 is the first level where we get a leaf. So we can say the maximum LCS we can get would be 4. Let's try how can we make 4 as our LCS. What would be required to make 4 as our LCS? That means in order to make whatever string that you get here, that only as the LCS, then these two strings should be exactly the same. And for these strings, this should come as a subsequence in these strings. Okay. And even if like we have, let's say more. Okay. There are two leaves at depth 6 and these are at depth 5. Okay. It would have a length of 5, length of 6, length of 7. But for these, if it has any subsequence of length 5 which is same as this, it would form an LCS of size 5. And what is the subsequence that it would be have? What would be its name? If you look, the first character in its name would always be whatever is given to the root node. Second character would be its next path that we take in coming to this. Whatever is here would be the second character for this. What would be the second character for this node? Would be whatever is here. That would be the second character for this node. Whatever is here would be the third character in its name. Whatever is here would be the third character in this name. Whatever is here would be its fourth character. Whatever is here would be its fourth character. For this leaf also, if you notice, its first character would be whatever is here. Second character would be whatever is here. Third character would be whatever is here. Fourth would be whatever is here. So basically the nodes at level 1 decide the first character in the name. Nodes at level 2 decide the second character in the name. Nodes at level 3 decide the third character in the name. Nodes at level 4 decide the fourth character. So in order to make the LCS equal to 4, what we need is all the nodes present in the first level should have the same character. Let's say all of them have 0. All the nodes present in the second level should have the same character. Let's say all of them have 1. All the nodes present in the third level should have the same character. In fourth level also they should have the same character. If in the first 4 levels, for a particular level, all nodes have the same character, same bit 0 or 1, then we can say that the first 4 characters in this string for all these nodes, or for all these leaf nodes also, the first four characters would be exactly the same. For this case, it would be here, it would be 0 1 0 0. For all the leaf nodes, it would be 0 1 0 0 0 1 0 0. It would start with 0 1 0 0, and then whatever is given here, that extra would come. Okay, again 0 1 0 0, and something extra would come. 0 1 0 0, then two extra characters would come. 0 1 0 0, two extra characters would come. But if we make sure that for the first four levels, each level has the same characters, then this LCS of size 4 is already formed. For these remaining nodes, we can just assign any character 0 or 1, it doesn't matter. We can just assign anything 0 or 1. It would not matter. We would already get an LCS of 4, and we cannot make it more than 4, you know. So if it is possible to make such an assignment, then we can say that your answer would be 4. If it is not possible to make such an assignment, then we can say that is there any other way to get an answer of 4? If till this level we are not able to, let's say at some particular level we are forced to have a mix of zeros and ones, then wherever we have 1, for all the children in its subtree, it would have 1 at this third level, and all the children, the leaf nodes in this subtree, would have a 0 at the third level. So it would not be able to make an LCS. And if you are saying that if you have a 0 here and then maybe further ahead you get a 1 and make it, then if you can make a 1, get a 1 here, you can use it there only. So this way, like, we can prove optimally that it would be impossible to make LCS equal to 4 if this assignment is not possible. If you cannot make the first 4 levels have all levels having same character, then the whatever is the minimum level for any leaf, that being your answer would not be possible. Then one less than that can be your answer, and this would always become possible because at any one particular level you can have a mix of zeros and ones, and then rest of the levels can have all ones or all zeros. So that we'll see. So basically your problem reduces to just calculate that how many nodes are present in level 1, how many nodes are present in level 2, how many nodes are present in level 3, how many nodes are present in level 4. If you calculate like the frequency of every level, at level 1 we have 1 node, at level 2 we have 2 nodes, at level 3 we have 4 nodes, at level 4 we have 1 2 3 4 5 6 nodes. So if you calculate these frequencies, that means now what your problem is, you have k number of zeros and n minus k number of ones. So you need to assign these k number of zeros. So if you are assigning zeros to this level, all these 2 should get zeros. If you're assigning 0 here, all this 1 should get 0. If assigning 0 here, all of them should get 0. So if you need to pick a subset of levels with which you would assign 0. So let's say you assign 0 at 1 and 4, then you should have at least 1 plus 4 5. So this 5 should be less than equal to k. If you can do that, as well as for the remaining 2 plus 6, that should be less than equal to n minus k. If you can make sure that if that is possible, then you would say a valid assignment is possible. Whatever is the minimum level in the node, that is your answer. If it is not possible, then you can, in any one particular level, you can have a mix of zeros and ones. You can say just 4 minus 1 would be my answer. So the answer can be only if I'm telling mn is the minimum level present, minimum level having a leaf, then your answer would be either mn if it is possible to do such assignment, or mn minus 1 if it is not possible to do such an assignment. Only these two can be your answers. So computing these levels and frequency, I hope that would be easy. Just run a BFS, compute the level for every node, and then iterate once and check for all the leaf nodes what are their levels. This way you can calculate the minimum level for a leaf node, and then iterate starting from first level to level number mn. Basically iterate through all the nodes and just update the frequency of all these levels, and then you get these frequencies. So in order of n you can compute these frequencies. Once you get these frequencies, how do we check whether k zeros and n minus k ones? Using that we can distribute them into zeros and ones. This is like a knapsack DP. I hope you would have got the intuition of that. So if let's say here we take, okay, here what was the number of nodes till here? 1 plus 2 3 plus 4 7 plus 6 13. So 13 nodes are covered till level 4. At level 5 we have 14 15 16 17 18 19 20. So the tree that I have drawn here, it has the value of n as 20. There are 20 nodes. Let's suppose k is something like 8. Okay, so if k is 8, that means we have 8 number of zeros and n minus k, which is 12 number of ones. This is present with us. Using these, sorry. So using these, using k number of zeros and 12 number of ones, you need to make a valid assignment so that sum of a subset of this is less than equal to 8 and the remaining subset value is less than equal to 12. So if let's say there were no nodes remaining here, if let's say the remaining number of nodes here was 0, that means the sum of this would have been exactly n. That means we need to find a way to divide this into exactly k and n minus k groups. So then it would be a proper knapsack problem, that you have some, let's say some weights, and you want to pick a subset of weight that sums up to exactly k, then the remaining subset would sum up to n minus k. Okay, so if this sum was equal to n, it would be an exact knapsack. And if there are some remaining elements, that just eases our problem, that a subset, we should have a subset that sums up to 8, or how many remaining elements are here? We have 3 7 13 here. Remaining elements here was 7. So we can move 7 zeros to here. So here either we can have 8 number of zeros, or 7 zeros move 1 there, or 6 zeros, or 5 zeros, or up till 8 minus 7 1 0. So if any subset can sum up in the range from 1 to 8, anything in, if we get any one sum in the range from 1 to 8, then we can say it is possible. Okay, so whatever remaining is here, whatever remaining number of nodes here is present here, we just need to check whether a subset of frequencies sums to a value in the range from k minus remaining to k. If there are 0 number of remaining elements, it should sum up to exactly k. If more the remaining number of elements, more it eases our equation. So we just need to apply knapsack in these and check if there exists any subset that sums to anything in this range, then our answer is yes, our answer would be mn, otherwise our answer would be mn minus 1. I hope the logic is clear. Now what would be the complexity to apply the knapsack? This sum of nodes, okay, so you have basically a vector having some values such that the sum of vector is less than equal to n. N is 2 into 10 to the power 5, and the k which I want to make a subset sum equal to k, this is also up till n. This can also go up till 2 into 10 power 5. So applying a knapsack DP would mean order of n into k, like applying general DP. using a state of dp ij, where it denotes if you are at the ith element, whether you can make a sum j or not. Using that general dp, its complexity would be n into k. But you know this is a 0 1 knapsack. So for the easier version of the problem, you can apply a general normal knapsack dp on this vector. Complexity would be n into k, and n and k both are up till 1000 only. So for easier version, this complexity would be accepted for the easier version. This is fine. Now for the harder version, n and k are up till 2 into 10 to the power 5. So we would have to optimize this knapsack dp. Now if you know about the an optimization of a 0 1 knapsack, that if you know about bit sets, then you can use bit sets to optimize the complexity of a knapsack dp to n into k by 64. So using bit sets, you can reduce the time complexity of a knapsack dp to n into k by 64. If you don't know about this concept, you may have a read about it. I'll explain it in short. That what is a bit set? A bit set is basically a data structure which is present, which stores. So if you are declaring a bit set of size k, it would store a binary, it would store a basically binary string of size k. It would store a binary string of size k. Now you can say that you denote using a bit set, you denote a state that 0 denotes that this value is not possible to make, 1 denotes that this value is possible to make. So initially when you have nothing, when you have no elements, then you can say, so if you index that, index 0 1 2 up till the kth index, if you index them, then if at index 0 you have 1, that means you can make a sum of 1. If at index I you have 1, that means you can make a sum of I. But if you have a 0 at index I, that means you cannot make a sum of I. That's what your bit set represents. And if you take this representation, then this you can say is your current state. This you can say is your current state of the dp. That you take a dpk, if you are taking a dpk, it would have k values of 0 or 1, whether it is possible to make or not make. And every time you iterate through every index of the vector, one by one you keep updating this dp. That's what you do in knapsack. So initially what you take is, initially your bit set would be 0 0 0 1. That making a sum of 0 would be possible by not taking anything. Making all the other sum would not be possible because initially you are considering an empty vector. One by one you iterate through all the values present in the vector. If you go to a value of vi, okay, let's say you iterate through all the values present in the vector. If you are going to a value vi, which is let's say 2, that means what you can do is, whatever sum was possible, what dp state do you write? You say that your dp of x, making a sum x, would be possible using vi only if either you take vi or not take vi. So if you don't take vi, that means if making dpx was possible already, then it would be possible, or if x minus vi. That's what your dp state is actually. That you write plus, or you only need to know true false, so you can write or operation here. That either if making x was already possible, then it would be possible, or if making x minus vi was possible, then it would be possible. If you look at this dp state, this is your dp vector. This bit set is actually your dp vector. So any state is 1, that means dp I is 1. So if you want to update the dp states using a vi, that means you can just left shift this by v positions. So wherever making a sum of x was possible, that would that is represented by this dp. And if you shift it left shift by vi, so if initially making a sum 1 was possible, left shift by vi, that means at the vith index one would come, and you take OR with left shift. So if you take with the previous bit set, you OR it with this bit set left shifted by Vi. If you take the OR, that means whatever bits that were set in initially, they would remain set, but by shifting it left, whatever extra bits got set, they also would become set. So by doing this updation for every Vi, we can, after going through every element in the vector, we can just get our final DP state, which would represent whether making a sum of I is possible or not. So after doing this updation, BSI just represent whether sum I is possible or not. Okay, what would be its time complexity? Going through all the index of the vector would be order of n multiplied by this OR with left shift Vi. This operation would take, since you are using a bit set, then left shift operation just you can do all the left shift or all these bitwise operations in, like, basically whatever was the size. If you are doing left shift Vi, you can do in Vi by 64 order. Okay, so bit sets are faster. This is the advantage of bit set, because here you are like storing 64 bits in one, you are processing 64 bits at once. So if you want to left shift by Vi, in general, if you take a string of size k, then doing a left shift operation would take order of Vi, but in a bit set, if you do, it takes an order of Vi by 64. So due to that, the sum of Vi overall would be like n only. And if you want to check, so basically you reduce your complexity to n into, you can say, k divided by 64. Okay, this Vi by 64 would come. Vi may go up till at max k. So order of n into k by 64 would be a time complexity. For n and k given as 2e5, this would become 4e10 divided by 64, which would be approximately, if you see, this would be like somewhat less than something like 5e8 types. If you divide 4 by, it would be 4e9 by 6, which would be something like 88 types, something like that it would come out. But actually it is a little bit more faster than that, and the time limit given here was 6 seconds. So in 1 second you can perform approx 1e8 to 8 type of operation. So it barely passes. Okay, so this complexity barely passes for the E2 case. Okay, so after doing this optimization, the code was accepted. So yeah, we can say that it passes. So I hope if you understood both the versions, we can move to the code. Okay, so let's move to the code for E. I'm only writing the code for the harder version with the bit set optimization. If you want to write the code for the easier version with n into k complexity, you can use a general knapsack DP to write it. I hope you can do it by yourself. That would be easy only. I'm only showing the code for the harder version, add directory written for that. Okay, so here what I do, I take the input n and k, and first of all I'll form the adjacency list for my tree. So the input was given in this form. I gave every parent from 2 to n. Okay, so this rep is basically a for loop. Okay, I've used my template here. I'll provide in the description templateless code. I didn't have the time to change it currently. So in the description, I'll provide the code without templates. Okay, but I hope these are simple things you can understand. So rep is basically a for loop from 2 to n. So I take the input, I get the parent of the ith node. So my parent array got updated. In my parent array, I assigned initially -1. So my parent array got updated, and in my adjacency list, if pi is the parent of I, then I can assign that for the child of pi is I. Okay, so I update my adjacency list. So input is taken, input part is done here. After that, my adjacency list and parent array is formed. Then I'll get the level for every node. Okay, level or the depth for every node. So I assign the initial level to 0 for all of the nodes. So here in my code, I'm taking the level of root node as 0. Okay, I'm starting from 0. I'd explained here as 1, so it would be converted like that in the code. So in my code, I'm taking the level of root node as 0. So I assign 0, then I run a DFS. In the DFS, I go to every child of the node. I update its level as level of x plus 1s and run the DFS. After running this DFS, my whole level vector would be updated. Level I would denote the level of the ith node. After that, I calculate the minimum level. Okay, the minimum depth. That would be my answer. So I go to every node. I calculate the frequency for every level. Okay, and for calculating the minimum, if adjacency I dot size is 0, that means I is a leaf node. So for the leaf node, I minimize the levels. Okay, so in mn, I would get the minimum level of a leaf node. Then in my vec, for doing the knapsack, what all frequency I would insert? I would insert till the minimum level. So from level 0 till mn minus 1 for a 0 based indexing. For 1 based, it would be till mn, but for 0 based, it would be from 0 till okay, till mn. Okay, in mn also it's 0 based. So mn is the minimum level in 0 based indexing only. So I iterate from 0 till the minimum level mn, from 0 till mn, and push back their frequencies in my vec. Okay, so I'll perform the knapsack in this vector vec. Okay, and I calculate the remaining. What would be the remaining elements are here? It would be the total n minus sum of this. So n minus sum of vec is my remaining elements. Okay, I calculate my r. After that, I apply the knapsack dp. I take a bit set which is initialized with 1. If I'm writing bs equal to 1, it would initialize with a number, a binary number representing 1. What is a binary number representing 1? It is this 0001. That is what our initial state is. Initial making a sum 0 is possible, making all the other sum is not possible. So my initial dp, the base case of the dp is bs equal to 1. Okay, and the size of the bs is taken as n, where n is like 2e5. Okay, so at max the size of the bit set can go up till 2e5. So I take n as the this 2e5 as the size of the bit set. I declare a bit set. Then I go to every element of vec and I do bs or equal to bs left shift I. Okay, this is bs is updated as bs or with left shift of the value of the vector. So I am iterating through all the values of the vector. I left shift by that positions and or it with bs. This way my bit set is updated. After that, I say my answer would be either mn or mn minus 1. Now here I have taken 0 based indexing. So for 0 based indexing, this level would be 3. So my answer is actually mn plus 1. Okay, in 1 base it is mn plus 1 or mn. Okay, so my answer is mn plus 1 or mn. Okay, so I initialize my answer with mn. Worst case it would be mn, and if it is possible to get any answer in the range from k minus r to k, then I can update my answer to mn plus 1. Okay, so I initialize my answer to mn, and if from k minus r to k, if in this range any bit set bs of I is set to 1, that means making that sum is possible. So if any bsi is true, I do answer plus plus and break out. If none of them is true, answer would remain mn only, and we print our answer. Okay, I hope the code is also clear. Is there any doubts in this problem? Okay, so if it is clear, we can analyze the time complexity. I've already explained the time complexity. This DFS would take order of n time. This input part also takes order of n time. Computing these frequencies also take order of n time. This vec also take order of n time. Accumulate takes order of n time. These are order of n. These are okay. But this bit set operation, BS is of size 2e5, and this OR operation would take by 64. So this complexity would actually be n into whatever is the size of BS, which is taken 2e5. Okay, the size of the BS divided by 64. Okay, n, or we can say vi. Vi into n by 64 would be the complexity for this loop. Okay, whatever value of the vector v is into the size of the bit set by 64. For this loop, this may run at max order of k times. Okay, so our final time complexity is this. This vi may go up till 2e5. This n is 2e5. So, or we can say vi may go up till k, n may also go up till n. So we can write it as n into k by 64. This would be our time complexity, and space complexity would be, these vectors are of size n only, but if you look at this bit set, this would be of size capital N, which would n by 64. In memory, it takes n by 64 only. So 2e5 by 64 space only it takes. So maximum space order would be order of n vectors only. So space complexity would be order of n only. Okay. So I hope this problem is clear. Any other doubts, if you have, you can ask, or we can end the session. Rating of this problem again, I don't know. Maybe the hard, like both easier and harder version were just whether you know about the bit set optimization or not. So due to that, maybe I'll say the easier version would be like 16, 1700 type, 17.8, or harder version maybe 1900 till that. I don't know. Okay. Any other questions? Did you prove C during the contest where you did here? During the contest, if you are asking about C, I had done with a different approach without proving that. Like the solution that I gave you here for C, thinking in the reverse order, was, I'll say, is more recommended solution and what you should think. But during the contest, for me, like somehow that didn't come to my mind, and I was thinking in forward order. And I did some bitwise operations and solved that problem. And I didn't had a proof that why that is working, but I had solved that problem. But yeah, but that was also non-intuitive, so that's why I didn't explain that in solution in the PCD. This was more intuitive solution, I'll say. But yeah, it was a bit tricky problem. I'm not, C would be like, I'll say at least 1600 type problem, or 1700 maybe. Maybe, I don't know. It was a good problem. Okay. Yeah, the number of summations in recently in Codeforces are get inflated due to various other reasons, which I don't want to discuss, but yeah, cheating and all. But there is no point of doing that. I hope you guys know. Okay. So no need to get demotivated if you're not getting good ranks. Okay. So okay. Thank you so much, guys. So I think we can end the session now. So goodbye, good night. Have a nice day.